Hi everyone, welcome back to the Nest. This is newsletter number 35, and this week we're going to be talking more about our new line of CozyCarb coolant-based carb heaters. I've got a list of 10 questions that people ask about the carb heaters, and it's something that I forgot to do last week that I said I was going to do, so we're going to go through that. I'm going to give a long-awaited D-Motor update. I will share the new pricing for these premium-based engines. We've been very industrious in the shop as of late. We have shipped a kit to Chile, a celebrity quick build kit, and we've got 2 Dakota Hawks that we've completed, sitting waiting to go out. They're just waiting for struts to come up from the States. The guys have been working very diligently on an FP303 quick build for a customer in the UK, and so they've just about got that ready to go, and we've got a Youngster kit that's going to be coming in, and so we're looking forward to building that. Last but not least, we have the 7th installment of the Youngster Tail kit build with Algy Yates. Algy's taken the time to carefully study the plans, and he has some solid tips for you this week on the building of the fin. Thanks for joining us every week. We really appreciate all the positive comments we've been getting that we receive. It spurs us on to get a video released every Monday, and I just received my Google AdSense account in the mail, so you're gonna see some ads soon. Sorry about that, but that helps us put out a better product video all the time. So without ado, here's our content for this week. Have a great day.
This is Fisher Flying Products. I'm Dave Hartner. Welcome to the Nest. Our video newsletters provide weekly insight into building and flying our 15 wooden aircraft designs. Plini Motori of Italy is a gracious sponsor of our channel. Plini is the manufacturer of the Thor 250 DS. CozyCarb Ice Prevention Systems is a proud sponsor of this channel as well. Please take the time to watch our videos to the end, as this assists us in the metrics that YouTube uses to rate our channel. Hit the like button if you feel that the content is worthy. We invite you to subscribe to our channel by clicking on the subscribe button and hitting the bell so that you are notified whenever we post our newsletters.
So I'm quickly going to go through the 10 questions I have with regards to CozyCarb. I know I've talked fairly frequently on recent videos about it, but we've been doing a lot of work to get this product ready and ready to go out the door, from printing labels to sourcing boxes to working with the physical products, ordering in fittings and making sure that all the hardware kit is put together, all the tubing and hoses and whatnot, so that when you go to put this on your engine, you don't have any issues. And we went through all of the instructions that we received from the UK from the previous company SkyDrives that we bought the system from. We'd clean things up so that from their instructions a little bit, and so anyway, it's ready to go. We're really pleased. We've gotten already a number of early orders from people and companies that already that supported it in the past. It's going to be available through Lockwood. It's going to be available through Aircraft Spruce and California Power Systems. And so we've got also Rotec up in Canada, out west in BC. They're going to be handling it as well. So you'll be able to find the parts and these kits through all of these other distributors, and you can buy them as well directly from the website. So, and now on to the 10 most asked questions about CozyCarb. So what engines can it be installed on? We have 2 different types of kits. One is for a 912 4-stroke based 4-cylinder engine, and one is a 2-stroke 2-cylinder Rotax engine, and a couple of different variants thereof. Do you need to have an on-off valve? This is a good question. No. This system's designed to run continuous in a continuous loop. There's no turning it on and don't turning it off. There's no remembering to turn it on or turn it off. So it's always there for you. And as compared to air-based systems that heat up the air and take charge, Our system doesn't heat the air intake charge. It just heats the carburetor body so that any moisture can't stick to it. So you don't lose any power with this system being on all the time. Do you have to change the cowl? This is a really good question. Some 912 setups especially are quite packed into the cowl. And there's just not a lot of room for anything else in there. And we find that with the offset of the carburetor aft by about 17 millimeters, there's usually enough room in and around the cone-shaped air filters to be able to push the carb back just slightly and install our system. And from there, it's basically tubing. And the tubing can be routed around your current systems or through the engine. And it doesn't add any bulk to the engine, and so therefore you can use your existing cowl no problem. How long does it take to install? About a couple of hours in the afternoon. I installed our first kit on Lionel's G1 and took my time with it, and it was just an afternoon, 2 or 3 hours, and I had it all done and bled. You have to drain the coolant out of a working engine to be able to install this, and so you have to then go back through the procedure refilling it, and that's the most difficult part really, is getting the coolant back in and then making sure that it's bled through the system and that all the hose lines are filled with coolant. Does it affect performance? Again, no, it doesn't affect performance because again we're just heating the carb body and not the intake charge. It does not change the performance of your engine, so you can again run it all the time. Can I install it? Yes, we have full set of instructions. It's a step-by-step, takes you right through it. I'd never installed one before, and the first time I did it, I got it right. It was not that difficult. The instructions are clear and easy to read. Can it be installed on certified engines? No. Not without... no, basically. This is for a non-certified installation. Now, some people say, well, isn't this the part that's available from Lockwood? Well, yes, it is, because they used to carry the SkyDrive's part, and so now they've been contacted that the CozyCarbs are back in production, and so they're relisting. Can you remove it from the carburetor later? With great difficulty. This CozyCarb and the carburetor are designed to be an interference fit, and so they have to be squeezed together with a press or in a vise. There's a procedure for this. It's well documented, but once you put that on and then you actually fill a small hole with Loctite to make a complete seal, so you can't be sucking air in or around where these two parts come together. So no, they don't come apart very easily at all. And where can I buy one? You can buy one, like I said, through Lockwood, through Aircraft Spruce, California Power Systems, and Rotec in Canada, as well as our website, www.cozycarb.com. So there's the 10 questions for CozyCarb. And now I'm going to give you a D-Motor update. D-Motor engines are a 4-cylinder flathead, fuel-injected, and now supercharged 4 and 6-cylinder 4-stroke engine that's available through us, and it's manufactured in Belgium. We've talked about this before, and we've been at shows with D-Motor, and a lot of people are asking questions about, hey, what's going on with it? COVID had a fairly serious impact with the people over in Belgium who are manufacturing this engine. It's caused them to rethink the whole operation and how they want to provide these engines and how much it costs to make them. These engines are a premium engine, but they're very much a boutique engine. They're handmade in one facility. All of the from the crankshaft to the conrods to a lot of the work is all done right in the one facility, and so it's a low volume, higher priced engine. And so we've gotten some new pricing from D-Motor going forward as to what their engines are going to be priced at, and they compete very well in certain very niche markets because they've got a supercharged version of both the 4-cylinder and the 6-cylinder engine. They can compete very nicely against the 914, but with more horsepower. And so with a horsepower limit of 160 horsepower on the 6-cylinder engine with the turbo, with the supercharger, they can operate in areas where Rotax just can't compete. And so there's 4 variants of the engine now. There's the normally aspirated 4-cylinder LF26T, fuel injected, 89 horsepower, and it's going to be selling for US $36,560. The 4-cylinder supercharged engine is 110 horsepower, LF26TS, and its price is $55,156. And again, these engines are small, and they've got the horsepower of the 912 IS, but can fly higher, and that's kind of good. It can take the horsepower right up to altitude. The LF39 6-cylinder normally aspirated LF39T is 125 horsepower, and it sells for $50,717. And lastly, the LF39TS, which is the fuel-injected 160 horsepower supercharged engine, is $67,880. So those are the current prices in the US for the 4 variants of the LF26 and LF39 plus their supercharged cousins. And we are going to be maintaining that moving forward as dealers for D-Motor in North America. And so if you've got any questions and you're interested in these engines for specific applications, then please call us. Yes, they are a little higher priced than the market, but we're going to be offering sort of premium service with it. And these engines fit into cowls that no other engine can fit into, and they can take horsepower to altitude where you might not be able to get it in another application. So that's our D-Motor update for right now. And now on to Algy Yates and his Youngster Tail kit build. Take it away, Algy.
Hi and welcome to the channel. Thank you for joining me on this episode where I go through the planning and start building the Fisher Youngster fin. I make some tools up which will help me with that, and hopefully you will get a few hints and tips. Remember, this is my way of doing things. It is not the only way. So let's get cracking and join me in the video. Hi and welcome to the fin build. As you can see, I've put some blocks already out on the bench, and I've attached the rear spar to the block work, ensuring that it is vertical that way. This end here has been squared off so it's vertical in both directions as required. I've made up this top reinforcing piece which goes against the very top rib to make up a T section. If I show you, hopefully you'll see over here, it sort of shows a out of scale cross section there. The cross section is far more accurate on drawing 2 there. So there's a slight anomaly in drawings. In point of fact, there's a few with the fin. The way the triangular blocks are put in is different, and when it comes to the rudder there's some other differences, but I'll talk about the rudder later on. But yes, the way the blocks are set up are shown differently on drawing 2 to that on drawing 2A. You get a piece of 3/4 block, as it says should be used. 3/4 block would not come all the way across to their blocking point because that's 1 inch. So it's going to be smaller, or I could make it a gapped block so there's a small gap in the corner. There's a secondary issue with the blocking on the leading edge. The rib itself is 30 millimeters across from here to here, and I've drawn in here where the gusset would go. It's 11 millimeters from the center line, so 22 millimeters wide, and 3/4 inch block is about 19 mil, so that means I have a millimetre gap between the block and the gusset, and that's with me doing a recessed gusset. So you'd have close to 2.5–3 mil gap if you're doing surface gussets. For a gusset to work correctly, it passes the loads going through the components by making the joint take shear load, and to do that it needs to have contact. So I want to make my blocks a little bit wider. There's no material supplied that's wider in that direction, so what I'm going to do is I'm going to glue a piece of the trailing edge of the elevator laminate that I've got left over onto the sides of this 3/4 inch material, and I think it's F9 material, and to make it a little bit thicker, and then when I run the router going across to make the joint, that will give us something sacrificial to actually produce the tapered requirement for there. Before I actually carry on with the leading edge, I'm going to be marking a center line, and I'm going to put this through on the table saw with an angle that's going to take off approximately 8.6 degrees, or as close as I can get to 8.6 degrees, off each side of the leading edge, and that will make life an awful lot easier because the ribs, I did the sort of calculation, 8.6 degrees here is that angle. So I've got that on each side. It makes it a lot easier than trying to plane it to match up and to do sort of routing and bits and pieces later. So by cutting that, I can then do the round off for the very front end slightly differently. You'll also notice that I've put in an extra bit of a line here, and that is to allow for the fact that the distance from here to there is greater when you're talking about the angle. I've actually measured the distances from there to there and transferred that onto the drawing, so a slight modification there to the shape. It's not going to change the rib, it's just for me to have an idea on the actual way I'm going to deal with everything at the front end here. And the top rib of the fin going across here goes to the very front of the fin itself, so that I will cut to that angle, so to that line, and then it'll be chamfered back, and it'll probably come back to about there as it goes up the so that's the one there. And looking at the drawing on the rudder, they've got that rib there extending further forward on drawing 2A, so it's drawn slightly differently to this. So I'm in two minds as to whether I'm going to cut the rib off short and have the laminate come down past, or whether I'm going to cut the laminate and have the rib come out underneath it. I think I'll probably go this method because it'd be easier. I can do all the rounding then with the routing, just cut off the excess in a similar way to the way I did the ends of the elevator. So these are the planning stages. Time taken at this point will save an awful lot of effort later. So the block here is to help support the rib that's going into here. Okay, so made up a couple of tools. I've made up a rib template. This can go onto the rib material. This side here will act as the center line, so I can mark it that way, flip it over, mark the other side. So this matches the shape as on drawing 2. This line here lines up with where it would meet up with the leading edge, and this is a continuation for the top rib of the fin, so I can mark that out and draw it, or the bottom of the rudder if I go all the way forward, as we discussed earlier. The other tool I've made up is this center finder. Really simple. All I've done is I've marked out equally at 30mm spacings along a section of wood here. I've drilled these holes all the way through at 2mm to take the nails, which I've taken the ends off so that they're rounded and won't cause any damage. And then I drilled at the back here 3.5mm almost all the way through, so I've still got just a 2mm hole there. And the idea is you can fit that onto the piece of wood, put your pencil in, twist it so that the nails are equally on each side, and run the pencil along, and there you have a centre line, and it's dead centre. I'll do that for the ribs as well, and that way I can make sure that when I mount this, because it's not going to be flat against the bench, I can have it set to exactly the right height so that it meets up with the centre line of the rib, and that's my way of making sure everything is correctly lined up. I'm just going to mark up the top rib, so that's my end point. I will just put a mark a little bit further back there, which is the datum on the template. And just use a couple of my small clamps just to hold that in position. I can draw around. Flick this over. Still got the datum in position. Draw around, and there we have the rib shape drawn on, which I can now cut out. I'll just cut across, and I'll use a sander just to sand that round. So here is the rib rounded off, centre line was marked as you saw, but I've also marked in this line above, which is to allow for the thickness of this reinforcing piece, and so that will sit there on the rib. I'll glue that in place before we start the assembly. It's going to be a lot easier to try and glue that now, make sure everything's all at 90 degrees, and I'll even glue in perhaps the extra little bits and the side blocks in while I've got it in position like this at this moment in time. Okay, prep work just about done. The top rib I marked out and shaped, and we've glued the reinforcing piece on, the F47, to give it that T shape. I've made up blocks at the right angles to fill in the corner pieces, and had to cut those down so that they'd fit in here. They'll get finish sanded to be flush with the bottom of the rib so that it sits correctly on the bench. Little infill pieces put in at each end, as is my want. I don't like having gaps. Next piece that's been done, for the front blocks, which I've yet to cut, I've bonded on the piece of laminating strip onto the square section to give it that little bit of depth, so we've got something to take off and it meets up with the gussets as discussed earlier. And the leading edge, centre line marked, has gone through on my table saw. I cut it down about 2/3 of the height. Leaves saw marks, so I then set up the sanding station with an 8.5 degree angle on there and finished it off so it's nearly to the bottom there. There's still a little bit of material left, but not a lot, so that is now correctly tapered to fit into position. Those of you who might be wondering what these are, that you might have seen them on my workbench in previous episodes. These are my glue testing system. It's based on an old method where you glue it up like this. The two legs at the bottom there will be sanded flat, and then it will be destructively tested in a vise. In days of old, we used to have to make up 3 of those. 1 we'd test ourselves and 2 for an inspector to test. It's just an old habit. I like to check each glue batch on any of the structural glue to make sure that it is cured correctly and has its strength. So that concludes this episode. In the next episode we will get all the ribs made, the blocks made, and this basic structure glued up. We might even get as far as fitting gussets. So until then, look after yourselves. Bye now.
Thanks again for watching. We try hard to bring you interesting content each week. To help us out, please like and share our videos if you feel the content is worthy. To receive the latest info from Fisher Flying Products, click the subscribe button and ring the bell. See you next time in the nest.